we should summarize this overestimation and underestimation for Riemann sums for these rectangular areas. So if the function is increasing on an interval, the left-hand rectangular Riemann sum, so if we take a look at this, if it's increasing, the left-hand Riemann sum is going to be an underestimate. So this one is going to be an underestimate. And you can see that as we touch on the left, because the curve is increasing, it's to do with the increasing nature of this function, that we leave this space, this gap underneath. Okay, so and the easiest way to kind of see it is if you actually just sketch a diagram of this. It's easy enough to sketch. And then the reverse is true for the decreasing function. So if we have a left-hand Riemann sum, so again, these are left-hand Riemann sums that I've drawn. So notice it touches, the rectangular height is determined by the left edge, but the function now is decreasing versus increasing. The Riemann sums become an overestimate, and you can see that the actual area, the area in the rectangles, is just a little too much. There's too much space above the curve. So this becomes then an overestimate. So if the function is decreasing, this becomes, this is now, the Riemann sum becomes an overestimate. Now, if we're talking about right-hand Riemann sums now, the reverse is true. So if I sketch any increasing function, okay, I can have any increasing function here. And if I draw left-hand Riemann sums for these, right-hand Riemann sums, we're talking about right-hand Riemann sums now. Okay, so if I draw a right-hand Riemann sum, so start at the right edge and then draw a rectangle, we can see that these right-hand Riemann sums are now going to be overestimates. We can see that this area then is an overestimate. So for increasing functions then, increasing, the right-hand Riemann sum is an overestimate. The left-hand is an under. And then the same could be true of some decreasing function. If I have a decreasing function and I use a right-hand Riemann sum, so again, this is a decreasing function, and I'm drawing a right-hand Riemann sum. So if I use a right edge to determine the rectangles, we can see the right edge is going to give us area above the curve. So this is now an underestimate. So if it's sloping down, the right-hand sum is a right-hand Riemann sum is an underestimate in this case. Okay, so now the downward, instead of an overestimate as I had here, if it's going downwards and right hand, it's an underestimate. Left hand over, right hand under. Okay, the reverse is true for left hand and increasing. Left hand increasing is an under. Right hand increasing is an overestimate. Left hand increasing under, right hand increasing is an overestimate.